Okay, we are going to start we're going to cover section 3.6, which is just a discovery section, and then we're going to be starting 3.7 day 1. In 3.6, we're going to learn what the derivative for the sine and cosine functions are. So before we get to the derivatives, let's quickly review what sine looked like and what cosine looked like back from trig. And I have them all preloaded on my calculator here. So I will turn on, I'll go down to sine first. Turn that one on only. Graph. And I have my window going from 0 to 2 pi, and then I have it from positive 2 down to negative 2. So if you remember the snake graph of sine, and then it keeps going. If I made the window bigger, you would see. So it finishes at 2 pi, it has an amplitude of 1, so period 2 pi, amplitude 1. And then cosine, if you remember, so I always called sine the snake graph. Cosine, I will turn cosine on, come on, and then turn sine off, graph. Cosine was our, I used cereal bowl, was a bowl shape. Started high, swooped down, came up. So there's cosine. So 2 pi is its period, amplitude 1. Okay, so now we're going to look at the, whoops, sorry, I'm going to make this a little smaller. Guess I can't. We're going to look at the derivatives. So, if I go back, you will see I'm going to type in sine. I'm going to graph 2 of these at a time. Turn cosine off. I'm going to graph sine, and then I've got the derivative of sine typed in right here. Remember with the n deriv on our calculators? So, we're going to see sine graph again, and then the second one, it's going to be in pink, is going to be the derivative of sine. And tell me if you recognize it. Well, I guess you can't tell me, you're not here. So, let me get this glare off. There goes sine. And now the next graph is going to be the derivative of sine. And remember, the calculator is doing a ton of calculations to get all those individual derivatives and plotting the points and filling in the pixels, so it's taking it some time. Oh, but doesn't that pink graph look awful familiar? Oh, looks an awful lot like our cereal bowl, and it is. So sine's derivative is cosine. So, our first discovery, number 1, is that the derivative of sine, this is saying I'm just taking the derivative of sine, we just found out that it equals the cosine graph. Now let's look at cosine's derivative. So when I have those loaded in here, so I'm going to go back. I'm going to turn on cosine, and then right below it is the derivative of cosine. I'm going to turn off the other two, and then we'll graph. So cosine's coming up first, that's in blue, that's going to be our cereal bowl. And then the derivative is going to show up. There it is. Looks a little bit like sine, except if you look, it's our sine flipped over. Normally it starts on the axis, goes high. Here, this derivative is coming down. So it's the reflection of sine. In other words, negative sine. So the derivative of cosine, our second discovery, is that the derivative of cosine is equal to the opposite of sine. Okay? Then there's one more thing that I want you to pick up on. If the angle's not just an x, what happens? Something happens in here, and you're going to see that. I'm going to show you one of these. So I'm going to go back, turn off cosine, turn off this one. We are going to look at sine 2x, and then the derivative of sine 2x. If you remember, what the multiplier on the angle did was it changed the period length. And by multiplying it by 2, let's just see if you remember. So there's one complete cycle of sine. Here's the second cycle of sine. So by multiplying that angle by 2, it made it finish itself quicker. So we got 2 cycles of it. So we really don't care about this second one here. Cover that up. So what I want you to see on this is that that red one is a cosine graph. Normal cosine serial bowl, except its amplitude got changed. If you look, it's maxing out at 2 and bottoming out at -2. So what's happening here, when I put in sine 2x, the derivative of this came out equal to cosine of 2x, because I still got 2 cycles of cosine there. I covered up one of them, but then its amplitude got multiplied by 2. And where that's coming from is it's the derivative of the angle. So when we do the derivatives of these trig functions, and I'll put it in terms, actually I'm going to do it right now. The derivative with respect to u, I like to switch it to u's, my bad, sorry people, the sine of some angle. If you want to take the derivative of sine, you first start here. The derivative of sine goes to cosine. Keep the angle, but then you have to multiply by the derivative of the angle. So I'll call it u prime. Same thing is going to happen when we do cosine. The derivative of cosine, first we start with the trig function. The derivative of cosine is always going to be negative sine of the angle. You keep the angle, but then you have to multiply by the derivative of the angle, because the amplitude gets affected. So these are the 2 rules we're going to be using today, right here. So derivative of sine is cosine times the derivative of the angle, and then cosine's derivative is negative sine times the derivative of the angle. Okay, let's practice. So that was really 3/6. Now we're going to move into 3/7. We want to talk composite functions. Composite functions have a function within a function. So I like to refer to them as the inside function and the outside function. So the inside function is the first operation done. It's like order of operations. the outside function is the second operation that's going to be done. So this first set of examples, I just want you to be able to tell me what's the outside and what's the inside. So example 1. Say I had f of x equals the sine of x to the 5th. If we were to substitute a value in for x, what would be the first thing a calculator does? So the first thing would be the inside function. In other words, what's the inside? The inside would work out x to the 5th. Then it would come back and figure out the sine ratio. So the outside function would be the sine. So outside is the sine, inside is the angle. Let's say we had y equals 2x plus 1 cubed. And we put in a number for the x. Where's your inside? Well, with parentheses, it's kind of easy. It's the stuff inside of the parentheses. So if you put a number in here, it's going to work inside first. So the 2x plus 1. The outside would be the cubing. So picking out the inside and the outside is what's important right now when we get to our derivatives. And then how about y equals cosine to the 4th of x? Remember what this means from trig. What that means is we're actually going to take the cosine of x, find that ratio, and then raise that to the 4th power. This is the math people's lazy notation so they don't have to use parentheses. So our inside, if we put a value there, it's going to find the cosine of x, get that ratio, and then it will put it to the 4th power. So your inside is the cosine, and your outside is the 4th power. Okay, so we are now going to have a shortcut for doing outside inside. If you remember, in order for us to do something like this, we had to expand it with Pascal's triangle. Now you're going to have a shortcut, and the shortcut is called our chain rule. So our chain rule says, first of all, it's for the derivative of composite functions. So for example, composite means you've got an inside and an outside. If you want to do the derivative where you have an inside and an outside function, so the derivative, you are going to do the outside derivative first, multiplied by the inside derivative. So it's outside first, where normally the outside was the second thing we did. You start your derivatives on the outside and you work your way in. So it's outside deriv multiplied by inside deriv. So let's practice. So all the rest of them, we're just going to be finding the derivative. Or it might say, the directions might say differentiate. Differentiate means find the derivative. So here we go. Number 2. F of x is the function x cubed plus 4 to the fifth. So what I want you to see is that there is an inside and an outside. So when we go to do derivatives, we start from the outside and then multiply by the inside. So our outside is this power. So I'm going to use our power rule where we take the exponent, you multiply it down, and subtract 1. That's our power rule. So 5 comes down. The inside doesn't change. Inside has to stay the same. So subtract 1. So I've taken care of the outside function. The inside are these two terms. So now I'm going to multiply by the inside derivative. So I'm looking at this first. Derivative of x cubed, I do a little power rule here, that's 3x squared. Derivative of 4 goes to 0. So there's my derivative. Because everything is multiplied here, this 5 will find this 3x squared. If you float it to the front, they find each other, they multiply. Our derivative is 15x squared times x cubed plus 4 to the 4th. We will spend lots of time practicing this. Number 3, I'm going to put it over here. Same thing, f of x equals the quantity 2x squared plus 3x minus 1 all raised to the 4th. So see this as an inside-outside problem. So we always start derivatives from the outside, which is our power rule. So the 4 comes down to keep this the same to the 1 less. So you never change the inside until you get to the derivative of the inside, but right now I'm only doing outside. So f prime, use your notation, 4 comes down, inside stays the same, subtract 1, and now multiply by the derivative of the inside. And it's each term at a time. The derivative here, it's a power rule. So the 2 comes down and multiplies by the 2 that's there. That's 4. X to the first. Plus, derivative here is going to be 3. Derivative of the minus 1 is 0. Well, do I have outside times inside? Might look like that to you, but not really. This inside derivative had 2 parts. See, over here it only had 1. Right now, technically, the 4 is multiplied by this, and then you've got a plus 3. I need this whole inside derivative to have parentheses. So now, what's going to find each other is because this is cubed, you're not allowed to distribute that back in there, but this one is to the first, so this 4 will get distributed into these 2. So our 4 gets distributed here, so 4 times 4 is 16x plus 12. That will stay in parentheses. And then my 2x squared plus 3x minus 1 cubed. Number 4. Yeah. Say we've got y equals 10, parenthesis, 3x to the negative 1 minus 2x to the 4th, all raised to the negative 7th. Okay, this 10, don't let that bother you. Multipliers are just going to carry along. So I want you to see that you have an inside and an outside. We've got an inside the parentheses and we got an outside power. So we're going to start with the outside. The power, following our power rule, comes down and multiplies, and that's just going to stay there as a multiplier. Using proper notation, I'm going to choose to go to y prime, because I am starting my derivative here. So negative 70. Inside doesn't change. To the 1 less power, so negative 7 subtract 1 more is negative 8. Now times the inside, and I see it's going to have two parts to it, so I'm going to use parentheses. So I'm only focused here, little power rule. Negative 3, x subtracting 1, I get negative 2. Now multiplying down, I'm going to have minus 8, x to the third. And then I can distribute the negative 70 into both of these. So negative 70 times a negative 3 is a positive 210, x to the negative 2. Then negative 70 times that negative is a positive 7 times 8, 560, x cubed, still in parentheses. And then I have my 3x to the negative 1 minus 2x to the fourth, all to the negative 8. All right, let's get to the trig functions. 5. Y equals cosine 4x. So again, remember, this is your outside function. This is your inside function. Inside is the 4x, outside is the cosine. So we always start with the outside. And if you remember from the beginning, cosine's derivative, and I gave you the rule. Let me grab it real quick. Right here. Cosine's derivative is negative sine, keep the angle. So we've got negative sine, keep the angle. Then it says multiply by the derivative of just the angle. So the derivative of 4x is 4. That 4 is going to float to the front. So I get negative 4 sine 4x. Number 6. Y equals, let's go cosine to the fourth x. Okay, anytime that's there inside, I like to write it with parentheses so I can easily see outside and inside. So I'm just going to rewrite this. Now I can easily see, here's my inside, this is my outside. I'm going to start with my outside derivative. So I'm going to go with dy dx, or dx dy, my bad, equals dy dx. I was right. Okay, so the derivative of y with respect to x. Okay, so outside is a power rule. So again, I don't care what's on the inside. The 4 comes down, keep this the same, subtract 1. So it's 4 cosine x cubed. Now I'm to the inside derivative. Well, I see a trig function and an angle. So we've got multiple outside-insides on this one. My outside is the trig function. So I'm here at the cosine. I know the derivative of cosine is a negative sine of the angle. Then I have to multiply by the derivative of the angle. Well, the derivative of x is just a 1, so I didn't really need that. So then simplifying this line, the 4 will find this negative 1, finds that 1, so that all just becomes negative 4. It doesn't matter if you leave the sign at the end of the problem or float it to the front. You can leave this with parentheses, or you can put the cube back here by the cosine where it's like it started, the beginning of the problem. So with parentheses or without, your choice. Try another trig one. Let's go y equals 1/2 sine 3x. So again, multipliers just carry along. Don't let them bother you. So trig functions. Here's your outside, here's your inside. So we always start from the outside. So when I do derivative, carry along the multipliers. Starting with this derivative, derivative of sine, remember, was just cosine. Straight up cosine, and then we multiply by the derivative of the angle. So it's cosine of this angle multiplied by the derivative of the angle. And now the 1/2 will multiply by the 3, so I will get a final answer of 3/2 cosine 3x. And let's go one more for good measure. Number 8. I equals -4 sine raised to the 3/4 of 5x cubed. So again, it's much easier for me to rewrite this with parentheses. Bring that out so I can see outside, inside. So what's to the 3/4 power is this sine of 5x cubed. This -4 is just a multiplier out in front. And I've got sine of 5x cubed. That whole thing is raised to the 3/4. Again, this multiplier is just going to carry. So my outside function that I'm starting with, the furthest thing outside, is my power. So that's going to come down and multiply by what's there, and then I'm going to subtract 1. So starting my derivative, -4 stays there, multiply by 3/4. I'll come back and take care of that. This stays the same. Subtracting 1, so I'm subtracting 4/4. It's going to leave me with -1/4. Now I'm to the inside. Inside, again, trig function and angle. You've got two more. You've got an outside and an inside again. So my next outside is the trig function. So I do the derivative of sine. Derivative of sine is cosine. I need an angle. It doesn't change. 5x cubed. So I've taken care of that. And now I've just got this derivative to do, which is a little power rule. So that's 15x squared. And then looking here, simplifying, these 4's will cancel. So I've got a -3. Can find this 15x squared. I'm going to float that to the front. So I'll have -3 times 15 is a -45 x squared. And then I've got these terms. And again, what order they come in does not matter. If I want to eliminate parentheses, I put the -1/4 here. If I keep parentheses, otherwise parentheses are gone and the -1/4 is right here on the sign. Cosine 5x cubed. And there it is. Okay. We will spend lots of time practicing this.